What's up? What's up? What's up? It's your boy, the network. Let me stop before I break this phone. Today's topic is section 3.28, configure and verify OSPF operations. This blueprint is really funny because it seems like we've covered this already, but nonetheless, we are going to configure and verify OSPF operations. This is a topic in the CCNP route exam. It's going to be known as a CCNP enterprise. This topic most likely will transition over into the new exam come February 23rd, 2020. However, it may be a different section number. Either way, I'm pretty sure OSPF is going to be on the CCNP route exam. Let's take a look at the exam blueprint and see where we came from and where we're headed. Hashtag lab every day. Okay, here we go. Implementing Cisco IP routing, exam code 300-101. Again, this topic, I'm pretty sure, will transition into the new CCNP and enterprise exam. However, they just may change the section numbers. Most likely OSPF will be on there. They will just probably change the wording of it. We just covered section 327, configuring and verifying OSPF path preference. Today, again, we're going to be doing configuring and verifying OSPF operations. And after that, we're going to move on to OSPF for IPv6, configuring and verifying that. Again, this kind of looks like the same. It's almost looks like the same topic as this. Configuring and verifying OSPF neighbor relationship. Verifying the operations is pretty much verifying the neighbor relationship and the routes and stuff like that. So to me, they go hand in hand. So we're just going to maybe sprinkle in a couple things that we might not have covered. I'm not too sure. I've recorded over 60 something videos on this exam. This is probably, in my opinion, the toughest exam in the CCNP route as of this date. There's only 3 exams. I believe they're going to knock it down to only 2 exams once it becomes the new one. So let's go ahead and jump right into it. Again, we talked about what OSPF is. It is the open shortest path first. It is a open source routing protocol. It uses the Dijkstra's algorithm, or shortest path first. Sometimes they call it just SPF algorithm, to find out the best path within the network to get there. Routers in an OSPF network are identified by a router ID, and how it is covered, or how the router ID is picked, is just these 3. I'm not going to read it all to y'all, just real quick. You can manually configure it by just doing router ID and then putting an IP address and say that is the router ID. That's how you explicitly define a router ID. Or if you don't do that, it'll do it magically for you, or automatic, however you want to say it. It uses the highest IP address of any up loopback interface. So it'll pick the highest loopback interface if you didn't explicitly say what the router ID should be. If there is no loopback, it'll pick the highest IP address of any up non-loopback. So any interface, any gigabit interface, any fast interface, any serial interface. As long as it's up, it'll choose that as the highest ID. If not, then the OSPF process, I don't believe, will start, because you don't have a router ID. So you have to define that. In the lab that we are going to run in Boston NetSim, it'll automatically pick it. We're not explicitly picking those. I believe we did that in a couple videos back. So again, these 2 topics kind of intertwine with each other. If 2 routers IDs have the same ID, basically you're going to have a duplicate router ID message. You can reset the process by just doing clear IP OSPF and then the area number or process number, and then process. That'll reset the process. It says here rest. Supposed to be reset the process, and then from there, well, you can change the router ID, and then you have to clear the process, and then you'll create a new router ID. Here's some show commands that you could do to verify your OSPF work. We've done a couple of these in the past couple of videos. Again, these topics intertwine with each other. I'm just going to run another lab for OSPF, and we're going to cover that. Here's some also debugging commands. I believe we did debug IP OSPF adjacency. I can't remember which video it was. We haven't done these 2, events and packet. So we'll see if we can run those 2 debugging commands in the lab. Y'all know what it is when y'all see this little girl. It's time to get our hands dirty with OSPF. So let's go ahead and fire up Boston NetSim and play with a little bit of OSPF. This is going to be a multi-area lab, multi-area OSPF lab. All right, so here's the lab we're going to be working with. Route Lab configuring multi-area OSPF. On the left-hand side, as you can see, is Pod 1. There's also Area 1. We got two areas, or two routers in Area 1. On the right-hand side, we got Pod 2 with two routers in Area 2. Each of them will have different process IDs. We need to pay attention to that. Process ID 3 for these guys, process ID 2 for these guys, process ID 1 for these guys right here. I wish they had like areas and stuff, or not areas, but arrows to point to these to let me know what exactly is running what process. So anyways, we got some generic commands right here. We got some show commands, plus the ones we said on the slides we're going to try to run. It says here to configure OSPF on P1R1, P1R2, and P1R3. Those are all three on that side of the network, which is Pod 1. We're going to start off with P1R1. It says here to use the proper area for each interface. Refer to the topology diagram. Remember to configure OSPF to announce the loopbacks. If a router is an ABR, you must configure each interface for the area it connects with. You should use the process ID for the routers as shown. So we got one process ID for this guy. This is what I need to pay attention to. One process ID for that guy, but he's got an interface in area 1, an interface in area 0. Then we've got the loopback interface. We'll just have to believe we're gonna have to use network statements. So I'm assuming that loopback gonna be in area 1, because if we put these two in the same network, they'll be in area 1. So let's go ahead and start off with that. Enable global config mode, and we're going to go to router process ID, router process 1, OSPF 1. Right, that's how and then we're going to do our network statement. So we're going to say network. We got a 192.168.1, a 192.168.1 plus a 10 network. So we're going to start with the 192.168s for area 1. 192.168.1.0 quad 0.0.255 area. We said area 1, right? The next network statement should be for 10. Also process ID 1, but area 0. So we're going to say network 10. What is that? 100.100.100.0 0.0.255 area. We said area 0, right? So area 0. So that's going to put that in the backbone area. Said something about ABRs too. Here's our ABRs. Let's not forget, right? An ABR is an area border router. One that connects, that's between some areas. This is between area 1 and area 0. This one's between area 0 and area 2. So what did it say? If a router is an ABR, you must configure each interface for the area. Oh, notice OSPF went from loading to full. So now we have an OSPF neighborship. You should use the process ID for each one. All right, so let's go to router 2. That's this guy right here. And do the same thing. Look at the topology and do the same thing. We've got 3 interfaces we need to work with. So let's start off with, we got 3 of them, but they're all in the 192.168.1 network. So we can pretty much use one network statement, but process ID 2, area 1. That's what we need to remember here. That's what we need to be careful about. Because I tried to do this earlier and I realized I was messing it up. So I went ahead and re-recorded. I'm going to keep it 100 with y'all. So now we're going to do router OSPF. What process number we said? Process 2. Area 1, right? So we're going to say, we're going to do our network statement and we'll say 192.168.1.0 should cover all these guys. 192.168.1.0 0.0.255 area. What area we said? Area 1, right? This guy's in area 1, right? Area 1. I believe that should take care of all of those guys. I don't remember what he said about the loopbacks. He said make sure that they're being advertised, and that should cover all of them. So that should cover all of these interfaces right here. So let's go to router 3. I believe we should see a neighborship form shortly on that other guy, on this guy. We'll see. We should see one shortly. There it is, right there. Now he's got a neighbor. All right. So now we go to router 3 and do the same thing. We got only one interface to work with. It's process ID 3, area 1. So we need to Go to user exec mode, privileged exec rather, global config mode, router OSPF process ID 3, and we're going to say our network statement should cover the 192.168.1.0 network, right? That should cover that. 182. And I believe that's just a loopback, right? No, that's a fast interface. So he don't have a loopback that he's going to be advertising. 168.1.0, 000.255, area, we said area 1, right? So process ID 3, area 1 for this guy right here, router 3, area 1. Okay, I believe we did that correctly. And that's for those 3 routers, right? That should cover those guys. He should have a neighborship form very shortly. It says here on P1R1, let's go to P1R1, it's right here. Display the routing table. What type of routes are on the table? O, IA, E1, or E2? Y'all remember what all 3 of these are? In the last video, I don't believe we covered what order they should be in, but I don't believe we covered what each one is. So either way, O is for an OSPF route. IA, actually you could just do a show IP route to see that. Okay, we got our neighborship on router 1. Oh, we've been at that. You see router 3, did he make his neighborship? He did. So all 3 of them got neighborships now. We are going to go to P1R1, display the routing table. No, my bad. The next step was to go to, from P1R3, ping P2R3's fast Ethernet 00 interface. So he wants this guy to ping that guy, which means he needs to go. There's only one way there, so that's what he's doing to ensure you have full connectivity across the network. So we're going to ping 192.168.2.50. Get out of here. Ping 192.168.2.50. Perfect. Okay, on P1R1, review the database of the link state advertisements. Review the LSAs are exchanged among routers. So we're going to go to P1R1. We are here. And we're going to remember how to do the check database. So IP OSPF what? That's right. You guessed it, database. And it looks like we have some type 1s here. We got some type 1s. We got some type 2s, right? Netlink is a type 2, I believe. Yeah, network is type 2s. We got a type 2. We got a type 3s. We got several type 3 interfaces here. I mean, type 3 LSAs here. What else we working with? Let's run that command again just to make sure we got all of them. I believe that's all we got here. We got type 1s. We got type 1s, type 2s, type 3s. Summary net, I believe, is the type 4, right? This says router link state. Oh, okay. Yeah, that's type 1. We got different areas. That's what it is. Notice area 0, area 1. So that's why we got different LSAs for different areas. They are being exchanged. On P1R1, display information about each device's neighbor on a per interface basis. So we're going to go to P1R1. We are here on a per interface basis. Show IP OSPF. And he says, we could do neighbor like this and see that we got 2 neighbors. Or we could just do interface and look at them that way. This is probably the best way. Just show IP OSPF neighbor. You could also do show IP OSPF interface, I believe. Or is that in connect? Oh, yeah. We could just do show IP interface. OSPF interface, rather. And notice we have that right there. You got a lot of information here, basically. That's for one interface. Here's for the loopback. And here's for the serial interface. On P1R1, display the OSPF interface statistics and information. Not too sure which one that will be. I believe it'll just be, let's see, we could just do show IP OSPF. Let's see what we got here. Statistics they want. Which one will give us the statistics? I guess. Not too sure. Let's check the answers and see what exactly they want us to run here. Oh, yeah. So we did neighbor interface is what they want us to run, which we just ran. So Now we can move on to question 7. General information about OSPF. That's just show IP OSPF. We knew that. So we got some information about the process number, the router ID. Y'all remember how it selects the router ID, right? It selected this active interface. Let's go back to the slides real quick. Selects router ID by, if we manually configured it by doing router ID and then router ID, but we didn't do that. So it picked the highest loopback, didn't have a loopback on that interface, on that router, I don't believe. And then it picked the highest non-loopback. So in that case, that was a non-loopback, I believe. 192.168.1.1 was, oh, it is the loopback. That was the loopback. So that's what it did. It picked the highest loopback as a router ID. And yeah, ran SPF how many times? I believe we can tell 7 times in area 1, 3 times for area 0. Task 2, route summarization. I don't believe we covered OSPF route summarization. Yeah, we did. Section 311. If you want more information on manual and auto summarization, check that video. But we're going to cover this anyway, just for the sake of this video. On P2R1, go to P2R1. Display the routing table. How many routes to pod 1 does this router have? Enable, show IP routes. Pod 1 should be, let's see here. How do we differentiate that? It says here pod 1 is the 192.168.1.0 network, pretty much. 1.0 network. So we've got 1 route here. Actually, 1, 2, 3, 4, right? Those 4 routes right there, the 1.0 network right here. 4 subnets, variably subnetted. That's pod 1. So this is pod 1 on the left-hand side. Pod 1 uses 4 contiguous Class C subnets. How can you summarize the 4 subnets with a single summary route? Well, basically, you got to come up with a summary address and just do IP route summary, I believe. We'll figure it out. Configure the summary route you noted in the previous step, pod 1R1, and the pod 2. So verify that the routes are summarized, and then the ABR should see the specific routes. And that's basically what it wants to do, is come up with a subnet, summarize the route here. So we got the 1, the 17, 32, and 48 networks, right? We got 30, the subnet masks are 32 to 28. So what we have in common is the 168.1.0 network. The bits here we have, man, y'all taking me back here. I forgot about summarization here. Let's take a look at what the answers are. Task 2, 168.1.0/26. All right, so interesting. I was close. We knew it would have been somewhere here. That's basically the commands we got to do right here. Go to P1R1 and do area range is how we summarize an address. So we're going to go to configure terminal, router OSPF 1, area range summarizes. That's how we need to remember. Then this is the border router, 192.168.1.0, 000 dot. We said to summarize is a /26. So a /26 should be 192, I believe it was. What was it? Yeah, 192. I'm sorry I'm taking the easy route for this, y'all, but we need to get through this. Let's see. We did that wrong. Area 1 range. 1 range. Match 192.168.1.0. 1.0. And then the IP address. IP mask. Oh, you do the exact mask. You don't do wildcard masks for this. 192. So we just going to do that. We need to remember that. And then on router 2, P1R2 rather, P2R1. So this guy on the border router, we do the same thing. Configure terminal router OSPF 2? No. 1. area 1, range 192, 168. We're going to summarize this with 2.0 because this pod 2 is 2.0. 255.255.255.192. So remember, when we're doing summarization, it's not IP summary route like for EIGRP. For summarizing routes for OSPF, it's area, the area number, and then a range. And that should summarize our routes. So we go to show IP routes. And we can see we got one route to get to the 1.0 network. Should be the same thing on the other guy too. Show IP routes. We got, did we summarize it? We didn't know. We summarized it. Not yet. Let's make sure we did that correctly. 2.0. So configure terminal area router OSPF 1 area 2 192 168.1.2.0 255.255.255. So when we're summarizing, that's what we need to remember. We're summarizing, we're not using wildcard mask. We use the actual subnet mask. Area 2 range. That's what we forgot. Jesus, we got the answers right in front of us. Let's go back to router that guy and double check. Go to this guy. There it goes. That's summarized now. Took a minute for it to summarize. Took a minute before it summarized, but we got it nonetheless. That's all I got for y'all today. I kind of struggle with this lab. Next video, we're going to do OSPF for IPv6. If you like this video, please comment, like, subscribe to the network.